Now, to begin with, today is eighth day of myself doing the chapter Organic Chemistry, some basic principles and techniques, chapter 12. Today is 22nd of July 2021. Now, I had reminded you yesterday regarding the attendance and regarding the punctuality. It's good that some boys are on time. I like that. Okay. Now, I had also told you that I'll be starting the next topic, subtopic in this chapter, which is called Fundamental Concepts in Organic Reaction Mechanism. That is what I'm supposed to teach you today and proceed further in the chapter. Fundamental Concepts in Organic Reaction Mechanism. Now, if you look at the main thing over here, the fundamental concept of the reaction mechanism, the definition, if you look at it, it is a sequence. The sequence of steps depicting the cleavage, means breaking of old bonds in substrate molecules. In substrate molecules, okay, substrate molecules are the molecules which are undergoing a chemical reaction. The reagent, or what you call the substance which is to be attacked, and formation of new bonds leading to the formation of products through reaction intermediates. Intermediate means the products which are formed in between the reactants and the products. Before forming the products, every reaction passes through an intermediate. So that is called intermediate. So in this reaction mechanism, it can be depicted generally like this. We have substrate. Substrate is attacked by the by the attacking by the attacking reagent, which results in the formation of products. So this is a general reaction. This is in general an organic reaction mechanism, how it is represented. Okay. Now, moving further, before going into detail and depth, let me tell you some more things about the mechanism of organic reactions. Some questions to be asked to ourselves, some questions to ask to you all. Okay. Now, how the reactions occur in organic compounds. This is that is the main target to be understood from this part of the chapter. How the reactions occur in organic compounds. What is happening? Whether the bonds are breaking in homolytic manner or whether the bonds are breaking in heterolytic manner, whether carbocations are formed, whether carboanions are formed, okay, whether free radicals are formed. So all these things we'll understand in this chapter, in this part of the chapter. The next point, if you see, breaking of bonds in organic compounds, this breaking of bond is called cleavage. It is called cleavage. It is done either through heterolytic cleavage or homolytic cleavage. This heterolytic and homolytic cleavage I will discuss very soon, quickly today itself in the next slides. There are two types of bond breaking. Remember for the moment, one is heterolytic and another one is homolytic. Okay. Then we'll be learning about the different types of chemical reactions briefly only in this chapter. The details will be learned in class 12. The terms used in organic reaction mechanism like substrate, what is the attacking reagent, what is the leaving group, and what is the product. And what are the attacking reagents after that? Electrophile. Electrophile, when I say, it is electron loving center. It is electron loving. Attacking reagents which love electron rich centers are called electrophiles, whereas the other one is nucleophile. So the attacking reagent which love nucleus, the positive centers, are called nucleophiles. And free radicals, you can have free radicals like fluorine having one electron, chlorine having one electron, that's a free radical. Okay. Then we'll be learning about addition reactions, simple addition reactions. We'll be learning about SN1 and SN2 mechanism, substitution nucleophilic unimolecular, substitution nucleophilic bimolecular. Then we'll be learning about elimination reaction, elimination unimolecular, elimination bimolecular. And finally, we'll be learning one example at least for rearrangement reaction. And to be particular, I will give you an example of a reaction which is named as Hofmann's rearrangement reaction. So this is brief of what I am going to teach you in this subtopic, in this part of the chapter. Okay. Now, let us move further in this chapter. Look at the types of organic reactions. the types of organic reactions. Basically, if you see, there are four important types of organic reactions which are there in your syllabus. But if you go to learn higher chemistry, then we can include some more types, but those are not in your syllabus. So the first four important types of chemical reactions, organic reactions are given. First one is addition reaction. The first one is called addition reaction. A plus A is equal to 2A. That's what. Okay. So here, nucleophilic, electrophilic, free radical, concerted. That means it is involving nucleophilic attack, electrophilic attack, free radical addition, or concerted addition. Okay. So these are addition reaction. The first type. Okay. You will be clear with nucleophilic, electrophilic, free radical, and concerted once we come to the specific examples in this part of the chapter. Then, the second type of organic reactions are generally called substitution reaction. Replace something. This also has examples falling under nucleophilic attack, electrophilic attack, or free radical substitution. Then, the third type of organic reactions are named as elimination reactions. We have two of them: elimination unimolecular, elimination bimolecular. Okay. Under substitution, we have SN1 and SN2 reaction, substitution nucleophilic unimolecular and substitution nucleophilic bimolecular. And the fourth type of chemical reaction comes under, it is called rearrangement reaction, where there is 1,2 rearrangement, alpha beta rearrangement, or pericyclic rearrangement. Olefin means rearrangement in case of alkenes, Okay, so these are the four types of organic reactions which we'll be learning in this chapter briefly. Okay, now moving further to the next slide. Coming back to the fundamental concepts in organic reaction mechanism. You try to understand this properly. In an organic reaction, in any organic reaction, the organic molecule, also referred to as substrate, whatever organic molecule I take for the reaction to happen, that is called the substrate. It reacts with an appropriate attacking reagent. That attacking reagent can be an electrophile or a nucleophile or a free radical, and that leads to the formation of one or more intermediates, and finally the intermediates stabilize down and form the products. So here general reaction is depicted below over here also. The organic molecule which is undergoing the reaction after being attacked by the attacking reagent, it is called substrate. Intermediate is formed, and then the intermediate convert into the products or any other side or byproducts formed in the reaction. After that, moving further, now you can see the heading over here, electron displacement in covalent bonds. Before moving to this chart over here, a very, very important chart in this part of the chapter, I would like to tell you about electron displacement. What is electron displacement? Now remember, most of the attacking reagents they carry either a positive or a negative charge. But the sad thing is, the substrate molecules, the organic compounds which are supposed to undergo the chemical reaction, they are neutral. They are neutral, which means they cannot be attacked easily. Therefore, for an organic chemical reaction to happen, it is very important. It is very important that the substrate molecules polarize themselves. The substrate molecule. Suppose I have a substrate molecule over here. Okay, substrate molecule. It's a bimolecular. So it has to polarize. It has to develop small negative and small positive charges so that it can be either attacked by an electrophile or a nucleophile. Okay, so nucleophile means it has to be negative, electrophile means positive. Okay, electrophiles carry positive charge. So if the electrophile attacks, it will attack this position. If the nucleophile attacks, it will attack this position. So electron displacement, it is possible in substrate molecules. It is possible in substrate molecules, and this electron displacement is possible because of the difference in polarity, difference in electronegativity in the organic substrate molecule. Okay, one is highly electronegative, the other one is highly less electronegative. After that, look at this chart very carefully. Under electron displacement effect in covalent bonds, we'll be learning about two types: polarizing effect and polarizability effect. Okay, the polarizing effect means the formation of charges in the substrate molecule by some external attacking agent, polarizing effect. Whereas polarizability effect by the molecule itself, it is temporary. Polarizing effect is permanent, whereas polarizability effect is temporary. Now, under the permanent electron displacement effect, there are three types. The first one is inductive effect, the second one is mesomeric effect, and the third one is hyperconjugative effect or no bond effect or no bond resonance effect, which I'll be dealing very soon today itself in this chapter. Now, moving to the temporary effect, which is called polarizability effect, there are the following types: inductive, what you call inductomeric effect, and electromeric effect. Something which is induced, okay, something which is induced, inductomeric effect and electromeric effect. So, looking at this one by one. So, we will start with this. We'll start with inductive effect in the next chart. So, this chart will help you remember. Okay. If I ask the question, electromeric effect is what type of effect? Is it a permanent or a temporary effect? What should be answer? Electromeric effect. What should be answer? Boys, tell me. I'm waiting for your answer. Electromeric effect is what type of effect?
So temporary.
Yes, you must speak. Okay, you must speak. Very good, very good. So that is how the question will be asked. The basic questions under this electron displacement effects. Okay. Now let us move to the next slide and see what we have. The first type of effect which I am supposed to discuss is inductive effect, or we call it in short I effect. We call it I effect, capital I effect. Now, inductive effect may be defined as the permanent displacement of electrons forming a covalent bond towards the more electronegative element or atom or group. Okay. Now, for example, let me draw the same example: CH3, CH2, 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 and then I write over here Cl, chlorine. Okay. So this compound is 1, 2, 3, 4, chlorobutane. Now, in this compound, if you see this chlorine atom is more electronegative than all these carbon atoms and the hydrogen atoms. That is why it will pull electrons towards itself. It will pull electrons across the covalent bonds towards itself. So this is how the pulling of electrons happen, like this. This is delta negative because it is electronegative. So what happens over here? Now, because of the pulling of electrons, all these electrons also start getting pulled towards the chlorine this way, this way. It starts getting pulled this way. So this movement of electrons towards the chlorine atom, because of its electronegative nature of the chlorine atom, it is called inductive effect, and this is responsible for the reactions happening in organic chemistry mechanism. Okay. Now it is a permanent displacement. Once pulled means pulled, it cannot go back till and until the time the group is over there. Okay. Now the inductive effect is represented by the symbol, the arrow pointing towards the more electronegative element or group of elements. So you can see the arrows over here. So to represent electronegative effect, you have to put an arrow pointing in the direction of the atom or the group which is more electronegative. Like we have some, if you look at fluorine, chlorine, bromine, iodine, they have electronegativity. This is 3.80. Okay, this can be how much? 3.60. This can be 3.50. This can be 3.40. These are the electronegative values. So among these, you can see electronegative. Fluorine is electronegative. Chlorine is electronegative. So electronegativity means what? It is the tendency of an atom of an element to attract the shared pair of electrons towards itself permanently. That is all. That is what we are going to learn under this heading, which is called inductive effect. And inductive effect is a permanent electron displacement effect we are learning in this chapter. Now, moving further to the next slide over here, let us get an idea about the types of inductive effect. Now, basically, there are two types of inductive effect. The first one is minus I effect, the other one is plus I effect. Now, in minus I effect, this X you see over here, this X, capital X, it is a group. It is more electronegative than the system. This is the entire system over here. So since this is more electronegative than the entire system, it will pull electrons across all the covalent bonds over here. Okay, that is why it is said to exhibit minus I effect. But on the other hand, if you see, there is a system over here, there is a group Y. Now this group Y is less electronegative than the system. So if it is less electronegative, the system will pull the electrons from Y. So here it is a case of plus I effect. Plus I effect. This one is withdrawing electrons. In the minus I effect, it is withdrawing, pulling electrons. In the plus I effect, it is giving away electrons. It is pushing electrons. Okay. So these are the two types of inductive effect which you must keep in mind. Now moving further to the next type of effect, which is called electromeric effect. Electromeric effect is called capital E. In short, it is also known as capital E effect. Now this electromeric effect takes place when an attacking reagent attacks a molecule containing a multiple bond. So a multiple bond is necessary. So here electrons of a pi bond, whenever I talk about pi bonds, it means that there has to be a multiple bond. When electrons of a pi bond are loosely held due to sideways overlap and easily polarizable, therefore when a compound having a pi bond approached by a charged reagent, an electrophile or a nucleophile, the electrons of the bond are completely polarized or displaced towards the one of the constant atoms. So example is given over here. There is a carbon. You can see over there. Have a look carefully. Carbon. It's an alkene. One bond is a pi bond. Another one is a sigma bond. So if I bring an attacking reagent, it can be anything. In the presence of attacking reagent, either a nucleophile or electrophile, the pi bond moves to one of the carbon atoms. So after the pi bond moves to one of the carbon atoms, we have a structure like this. If the pi bond moves in the right direction, then this carbon becomes negative charge and this carbon becomes positive charge. So we have a charge species over here. Now if I bring an electrophile carrying a positive charge, this electrophile is going to attack this carbon because it is carrying negative charge. So this type of effect, it is called electromeric effect. It is called electromeric effect, and this effect happens in the presence of an approaching or an attacking reagent or an electrophile or a nucleophile. What is nucleophile? Nucleophile is like this, Nu double dot dash. That's a negative charge. Okay. Now I hope electromeric effect is clear. I can tell you the definition once more. Now this electromeric effect, you can define it in this manner. It is the complete transfer of shared pair of pi electrons of a multiple bond to one of the shared atoms, over here. Okay, in the presence of an attacking reagent. That means for electromeric effect to happen, the presence of an attacking reagent is compulsory. It is compulsory. Okay, so that you have to keep in mind. Okay, so that is important over here. Now moving to the next slide. We'll see the types of electromeric effect. I'm writing over here types of electromeric effect. There are basically two types of electromeric effect. Have a look at the screen. Now, there are two types of electromeric effect. The first one is called positive E effect. The next one is called negative E effect. Now, as I have told you, electromeric effect is possible in organic compounds containing double bonds, multiple bonds. So, if I bring a hydrogen ion H plus electrophile, if this H plus approaches this alkene, so displacement of the pi electron will happen. Either it will go this way or it can go this way also. Okay, so in the presence of an electrophile, this hydrogen is acting as the electrophile. So the displacement is happening to one of the carbons. So once this electron goes that side, this hydrogen is attaching to that carbon only on which the electron displacement has taken. See, this hydrogen is attaching to that carbon to which the electrons are displaced. So that means over here the electrons are falling on this carbon and is carrying a negative charge. After that, the electrophile, it is attacking that carbon only and forming a bond. Okay, and the positive charge is remaining over here. So this is plus E effect. Okay, this is called plus E effect. Here, how can I define this sentence? When the electrons of a pi bond are transferred to that atom of the double bond to which the reagent gets attached. The reagent is attaching over here and the electrons are also coming over here. That time it is called plus E effect. Otherwise, if the electrons are falling on that carbon but the attacking reagent is attacking the other carbon, joining with the other carbon, that time it is called minus E effect, minus negative electromeric effect. So these are the two examples, two types of electromeric effect. Okay, so I think this is clear to you. So you please follow, don't get agitated or terrorized while revising. I have tried to make very simple understanding of this chapter to all of you. Okay, so you please follow my video and the slides, the PowerPoint slides very carefully. Everything will be very, very clear and it will remain in your minds for a longer time. Okay, now let us compare in the next slide. In the next slides, I have put a comparison, a brief comparison about the two types of effect, that is I effect and E effect. I is inductive, E is electromeric. Comparison is done. Inductive is a permanent effect. Electromeric, it is a temporary effect. Number two, in inductive effect, the presence of multiple bond is not essential, not necessary. But in electromeric effect, the presence of multiple bond is compulsory, it is essential. Number three, in inductive effect, the polarity of bond is essential. If there is no polarity, reaction will not happen. But in the case of electromagnetic effect, the polarity of the bond is not essential. The polarity is created, it is developed by the presence of an electrophile or a nucleophile. Number four, partial charge separation takes place. Whereas number four, under electromagnetic effect, complete charge separation takes place. Here it is only partial, here it is complete. Now number five, no ions are formed after the reaction. Okay, products are formed which are neutral. But in under electromagnetic effect, ions are formed. We will get ions. Okay. Number six, inductive effect, attacking reagent is not required. It is not required at all. Okay, for I effect. Inside the molecule, a more electronegative atom or group is required. But in the case of electromagnetic effect, attacking a reagent is required. Otherwise, you cannot see electromagnetic effect. Number seven, under inductive effect, the displacement electrons do not leave their molecular orbitals. However, distortion of electron position cloud takes place. That means the shape of the molecule gets distorted because of the inductive effect. And number seven, under electromagnetic effect, the displacement electrons leave their orbitals and attain a new position. Okay, that's what we have seen in the previous slide over here. It's giving a new shape over here. It is forming a new shape. Okay, then in inductive effect involves slight displacement of electrons, movement of electrons, but here it involves complete transfer of pi electrons. Here it is displacement of what electrons? Sigma electrons. They are shifting like this. But here involves transference of pi electrons like this by using the arrows in this manner. But here on the covalent bond we put arrows like this to show inductive effect. So this is a comparison. It may help you answer up to 2 or 3 marks in organic chemistry. Okay. Now, my dear students, moving to the next slide under resonance. Resonance, in short, in simple language, it means delocalization of pi electrons. What does it mean? It means delocalization of pi electrons in organic chemistry. Okay, now have a look over here. There's an example of benzene given over here. It is shown. Resonance is involved or invoked when more than one valid Lewis structures can be written for a particular molecule. So it is been shown over here. Okay. The actual structure is an average of the resonance structures. I will show you one example by introducing a new slide over here. Just a second. Now, have a look. Resonance in uh, phenol molecule. Now, for resonance in phenol molecule, watch very carefully. This is supposed to be the structural formula of phenol, an organic compound having alternate single and double bonds like this in the ring. Now, like water, if you remember the formula of water, the structural formula of water, HOH, this oxygen has got two lone pair of electrons. Okay. In a similar way, this oxygen also has two lone pair of electrons. So, now what happens over here? Now, in resonance, one of these lone pair of electrons, it falls over here and gives a double bond. So, the first structure, the first resonating structure becomes like this. Oxygen, one lone pair is there, left, hydrogen is there, and this becomes a double bond. And then we have the ring, but in the ring, because this is forming a double bond over here, this pi electrons will get disturbed and it will fall on this carbon. So we have electrons and negative charge over here, and then there is a double bond, another double bond, and this oxygen will carry a positive charge because it has one extra bond, 1 2 3 bond. That's why it is carrying a positive charge. Okay, now this is the first resonating structure. Now the movement of pi electrons has started. The first pi electron movement has started over here. Now in the next step, again this pi electron will fall on this and form a double bond. This will get disturbed, it will fall over here. So we get another structure. We get another structure which is like this. Which is like this. Electron pair, positive charge. Okay. There is a double bond. Then the ring. Then the ring over here. Double bond here. Two electrons, negative charge, double bond over here. Again, this is the second structure. Okay. Second resonating structure. Again, this will fall down over here, form a double bond. This will get disturbed, it will fall on this carbon. So we have the next structure, OH plus sign, double bond, and then we have the ring over here, double bond, and this is a negative charge. And again, what will happen over here? This will fall over here, and this will go back to its own position. So we have oxygen, two lone pair, hydrogen, single bond, and then the benzene ring with alternate single and double bonds. Now compare this one and this one. Compare. It is same. Only the position have been changed one round, over here. So whatever you see over here, resonating structures. These are all resonating structures. Now these are called the resonating structures, and this is an example of resonance. Now resonance, if I go further to define, the definition of which is never asked in class 11 examination or class 12 examination, but you have to get the idea in simple language. Resonance means delocalization. Delocalization. Resonance means delocalization of pi electrons. Delocalization of pi electrons. This is what you have to keep in mind. So I have shown you the example of resonance in phenol. Now, if you define, it is a phenomenon in which a molecule is represented by several electronic structures. Several structures which are electronic because they are carrying charges. Positive charge, negative charge, positive charge, negative charge, and so on. Okay. And these electronic structures, they do not differ much in their energy content and are obtained by the oscillation of pi electrons. And this is called resonance. It is called resonance. Okay. Now, there is one more word which is called resonance energy. Which is called resonance energy, which I'll explain you in the next slide. Resonance energy. Have a look at this. Let me briefly explain what is resonance energy. Now, resonance energy is the difference between the energy content of the resonance hybrid. So now for phenol, I can write the hybrid this way. The hybrid is this way. We have to write the hybrid this way, dotted, dotted, because these pi electrons are going round and round. So I put a circle inside. So this is the resonance hybrid. Now, this resonance energy is defined as the difference between the energy content of the resonance hybrid and the energy content of the canonical structure. Canonical structure means any structure of this compound which is possessing the least energy. So whatever difference is there, that is called resonance energy, the energy with which the pi electrons are moving round and round. Okay, so that was all about resonance and resonance energy. Now, in your textbook you will find examples of some organic compounds or some inorganic compounds, resonating. Like, for example, I will give you one simple example by taking an example of carbon dioxide molecule, resonance in carbon dioxide molecule. If I proceed further and draw the structure of carbon dioxide carbon dioxide molecule, it is like this. Carbon dioxide, CO2, carbon and oxygen will have a double bond, so, and the oxygen will have a lone pair of electrons. So if it will start resonating, it is shown like this. It is shown in this manner. Suppose this bond over here, it moves, say it goes this way, it comes over here, it is possible. Okay, then we get a structure like this, resonating. Okay, two electrons over here. Also I can put two electrons and a negative charge, so there is a triple bond over here. Okay, that happens, that is possible. Okay, on one side carbon triple bond, other side I can have this can be negative, just a second, and this will be oxygen over here, and then there is a positive charge over here. Okay, and this oxygen will carry a negative charge. So resonance means these are pi electrons, this is pi electron, this is another pi electron. So if there is movement of the pi electrons from one position to the other, and which results in the formation of charge species over here, okay, carrying charges, there is polarity, then that comes under a topic which is called resonance. Okay, we can have plenty of other examples also, like for urea is also there, benzene is already there, carbon monoxide is also there. Okay, so you just refer your textbook for this. They might not ask you the examples for the resonating structures of these compounds. Okay, now what is the use of resonance? The use of resonance is very important. It is helpful in calculating the inter-ionic distance between compounds. We can know whether the given bond is ionic or it is covalent from the concept of resonance and resonance energy. No, and after that, by using resonance we can understand several organic chemistry, facts, observed facts, on the basis of the concept of resonance. Okay, now it is already time, it is already 9:11. What do you have in the next period, my dear boys? What do you have in the second period?
Uh, Maths.
Okay, so I'll stop the class over here. Okay, I will not differ. In the next class, I'll be doing in detail about this effect only. That is resonance and resonance effect, by giving some more examples. Okay, so just hang on over there only. Let me take the attendance before you leave the class. Okay. Okay, attendance is taken. You may leave the class. Have a nice day. Thank you so much.